Hi guys, we're going to work through section 1 of chapter 1 is on set theory, starting with set notation. So just a bunch of notation, symbols and whatnot that you need to know throughout this course. So first off, just kind of use a little example here. We're going to say our class is what I call the universal set. So this is everybody in our everyone in our class is called the universal set. That's the only thing we're working on is this class. So we use capital letter U for that. And we say that each student is an element of U, the universal set. Okay? So you're all an element in our class. So moving from that, talking about what's called a subset. All right, I'm going to say everyone in this class with blue eyes, I'm going to call them set B. Okay, we'd say B is a subset of the universal set because all the people in here that have blue eyes, you're part of the universal set. So you're the subset of that, a subset. Okay, we would also say brown eyes or green eyes, they're all subsets. And I would also call all right-handed students set R. Right, that's another subset. Okay, so R is blue-eyed people, or sorry, B is blue-eyed people, R is right-handed. So think about everybody who is both right-handed and has blue eyes, we call that the intersection of sets B and R. Okay, important term there, intersection. That's how we define, that's how we denote it. With that little upside down U for intersection. Right? That means both B and R. All the people who are both right-handed and have blue eyes. Might be a couple of you that are in that boat. So that's intersection. Next thing I want to talk about is union. Okay? So now I want to think about everybody in this class who is either right-handed or has blue eyes. We call that the union. So think about everybody in this class right-handed, right, that's part of the group, but if also anybody that's blue eyes is part of the group also. Right? They don't have to have both now, it's just one or the other, or it still could be the people with both. All right, we call that the union. We use it's basically a big U to represent that. We say B union R. And next term is complement. All right, so we're going to say that left-handed people, or we could also include ambidextrous people, but we can say left-handed people because they're not right-handed. So we say the left-handed people in the class would be the complement of R. And we denote that little symbol right there, a little tick mark, looks like R prime if you've taken calculus, just means the complement of R, means everything that's not R. Right? Then the last thing, this is kind of cut off here, but all freshmen in the class, we call that the empty set because there's no freshmen in this class, which there shouldn't be. So the symbol for that looks like that. That's the empty set. Okay, so that's some of the terminology to start. All right, this is an important concept to talk about before we move on. I want to talk about the Applebee's or the Starbucks version of the word or. Okay? Interpreting the word or in public voting can be kind of confusing sometimes. So I want you to think about two examples. So one, if you're sitting at Applebee's or any kind of restaurant, and your server asks you if you want fries or a salad. And you're going to pick one. Right? If you go to Starbucks, you get a coffee, they might ask you if you want cream or sugar. So we're going to think about what is the difference between or, this or, and this or. Okay, there's a difference there. What is that difference? Well, the Applebee's or, and I go in there and they say fries or a salad. If I try to get both, they're going to charge me. Where at Starbucks, it's assumed you could get cream, you could get sugar, or you could get both cream and sugar. All right? So in probability, we want this one, okay, this one. Basically, this, or both. That's what when we talk about or in probability, that's what we're talking about, okay? So we want the Starbucks or. All right, so next part of section 1.1 is called the Cartesian product. All right, about Cartesian coordinate planes, your old XY axis, or your XY plane. So Cartesian product. All right, let's just say I have two sets. I have set A and set B. Okay, set A is just these three numbers. Set B is these three letters. All right, the Cartesian product is when it's denoted as this. It looks like A times B. You're not actually multiplying them. We're basically putting them as ordered pairs. So in this case, all we really do, A is 1, 2, 3, B is A, B, C. So my Cartesian product to AB is I just match up 1 with A, and then I go 1 with B, 1 with C. So there's 1A, 1B, 1C. Okay. Then I just do the same thing with 2. I match up 2 with A, there it is there. 2 with B, there it is there. 2 with C, so on. And then same thing with 3. Then I have 3A, 3B, 3C. If the order was flip-flopped, all you do is you just flip-flop the order in the parentheses. That's it. If we do this, in this case we have 9 pairs. We can tell that without actually doing it. Basically, if I have 1, 2, 3, 1, 2, 3, the number of pairs we're going to have is just you multiply the two together. Okay. So, in other words, that's this right now here. And when we say this, lowercase n and in parentheses, that means the number of elements in set A. So this means number of elements in set A, which is 3 right there. Number of elements in B, 3 elements right there, 1, 2, 3. 3 times 3 equals, not 3, long summer, 9. Go. So we can easily tell how many are going to be in that by just multiplying how many are in. Okay, and that is it for section 1.1. Not a lot to it. Next section 1.2, we start to get into Venn diagrams, which you've probably seen before. Okay, let's see some stuff with that. All right, but that's it for 1.1. Let me know what questions you have.